Hello guys, today I'm gonna clarify a topic for coordinate geometry. It's a real basics before starting the topic about straight lines. So everyone who are not sure, not confident about coordinate geometry, that he or she knows perfectly. So just get back to the point and we explore the following things. How to plot the points, and what just generally Cartesian plane is, or number plane. We also explore the distance between 2 points as a very often application in straight lines and probably geometry, in coordinate geometry. And so midpoints, how to find midpoint of the segments. So idea of the gradients that's necessary for straight lines, and parallel and perpendicular lines on the plane. So basically we explore in terms of gradients, which gradients they need to have to be like parallel to each other or perpendicular. All right, let's get started. So first of all, we need to input the idea of number plane. So basically number plane is just specified of ordered pair of numbers x, y. So normally we use two axes, y and x, that are perpendicular to each other, and like set of points on this plane basically represent Cartesian plane, right? So in order to plot the point, first of all, we need to have the coordinates. So any point, let's say A, let's say it's here, should have two coordinates. The first is x, the second is y, all right? So the first coordinate, how to basically plot it. So you need to know the exact value of your coordinates. Let's say it's 3 and 2. Okay, we have intersection point, its origin. It has two coordinates, 0 and 0. So in order to plot, first we need to start from the origin, and we always start from it. And then we just count 3 steps, each one by 1 unit, in order to arrive to 3, because the first coordinate is x and it's positive, so it's positive 3. All right, so we count in a way where x is rising and it has positive values. So we count like 3 times, all right? And then we need to count also 2 times, 2 steps up, all right? In this case, let's say the scale is a bit bigger, but normally you should have from the same scales. From here, you just lift it up by 2 units, and that's how you arrive to the point A. Or there is another approach where you have A, you just need to put 2 perpendicular lines, and intersection with x-axis and intersection with y-axis will definitely show you the coordinates, okay? Not necessarily the coordinates should be whole numbers. In this case, they're whole, but you might set up another point, let's say M, with coordinates 3.5, and let's say 2.5 as well. Okay, so in this case, you just use a unit step and divide by 2 in the end. So in this case, if it's 3.5 for x, and this is the next is 4, so you have the middle point on midpoint here, and that's x coordinate for M. Then you need to lift up 2.5 times, so it means 2.5 steps. And let's say this is 3, this point has coordinates 3 for y. So basically used again a midpoint here. And that's your point M, okay? That's your point M. Or you start from 0 and do basically 3.5 steps to the right of x, and then 2.5 steps up. Okay, that's how you arrive to the point M. That's M, that's A. All right, the coordinates might be negative. In this case, you need just to go backward. For example, this part of the x-axis is negative, as well as this part is also negative. All right, so for example, let's say you have point B with coordinates -1 and let's say 1. All right, so we need to step back by 1 unit from the origin. It's here, so this -1, and then lift 1 unit up. Okay, 1 unit up. That's your b. Okay, so I think you got a main idea how to plot how to plot the points. And now we just move to the quadrant because we need to explore Cartesian plane in full. So that's why we put 2 lines. This is the origin again. And what about quadrant? Quadrants. There are actually 4 quadrants. So quadra like 4. So basically it's the same as like quadra like quarter. So 1/4. And indeed, so we have this quarter of the plane, this quarter, and the last quarter. So, and we normally start counting from the first quadrant, which represent the positive values for y and positive values for x. That's first quadrant. And then we just move anti-clockwise, all right? So that's the second quadrant, the third, and the fourth. All right, why do you need the quadrants? So probably you might be given that your object, your triangle, is in quadrant 3, for example. Okay, it means it's here, or the point is there. All right. So why do we need points? So probably we might have them in order to connect and arrange the shape. So for example, we might be given like 4 points in order to arrange specific 2D shape. Yx, let's say this is A, this is B, this is C and D. Right, and if we connect with lines, we'll get specific shape, right? And so probably you might need to prove that having like specific 4 points with specific coordinates, you just need to plot them and just visually prove that you have rectangle, all right? So, but here I just want to stop and tell you that, for example, if you take 2 points B and A, you understand that from origin, they are in x direction, means in horizontal steps, they have the same number of steps to make, right? So it means x coordinates of those points will be the same, okay? Let's say it's 1, for example. So x coordinates for both points will be the same and equal to 1. So we can write 1 and 1. Okay, but what's the difference? The difference is what in y coordinates. For example, let's say this is 3 and this is, let's say, 0.5. All right, so we can say that for A, y coordinate is 0.5, for B is just 3. Okay, if you compare B and C points, now they are on the same level, right, for y. So that's why C should have 3 as a y coordinate, okay? But probably x coordinate is going to be different. So, but if you have a look at D, so we will have the same x coordinate as for C, but it's on a 0.5 level for y. So, okay, let's say this is 3, and both C and D should have 3 as for x. Okay, so you might begin those points and just you need to restore the shape if you connect like A, B, C, D contour, all right? And maybe you need to describe what kind of shape you'll get, like quadrilateral, maybe parallelogram, maybe just rectangle, maybe square, okay? In this case, it's definitely rectangle, right? Because if you just measure distance between 2 points, it's actually from 1 to 3, so how many steps you need to make in order to start from 1 and arrive to 3, obviously 2. So in order to measure distance, you just need, so how to work out distance, that is, that AD represents. It's just basically the difference of x coordinates, right? 3 minus 1, that is 2. Also, you might be asked to define distance CD, which is basically from 3 to 0.5. So as you remember, distance is always positive value, right? But however, if you have, let's say, distance, you need to measure distance between point M and say N. In this case, you cannot say just simply difference in X and Y's. No, this is another rule where you need to apply Pythagoras theorem in order to find distance Mn for this sort of segment that's not parallel to x-axis or y-axis. All right, so I hope the first point we know how to do. Probably it's not like maybe we didn't like consider all possible problems relating to plotting points, but this video is supposed to be pretty short, but to cover a whole coordinate geometry at once. So that's why we just be focused on key points. All right, let's go to exploration distance between 2 points. Okay, so for this reason, simply we input Cartesian plane, y-axis, and let's say we want to define the distance between 2 points. The first point A, the second point B, and we want to measure, not actually measure, but calculate. Of course, you can measure using the ruler, but in most cases, you need to calculate the distance. So basically, find the length of segment AB. So distance, right? In case where segments were vertical or horizontal, we simply need to subtract, have a difference of coordinates. In this case, we're not eligible to do. However, we can say that if we put two lines that are parallel to x-axis and y-axis, they will have intersection at some point, and they will arrange 90 degrees angle or right angle. So let's say this C is the point of intersection of those lines. And what can you say about triangle ABC? This is right angle triangle, right? And for right angle triangle, and for this sort of triangle, we can apply Pythagoras. So in this case, AB is the height, and we have two other sides, AC, that's shortly A, and BC, that's shortly B. All right, so in order to find height, and that's our goal, we just need to take the square root of sum of two squares. All right, we square up two sides or two legs, A and B, and then add them up. All right, that's how we normally should find height, hypotenuse, and that will be equal to AB segment lines. All right, now what we need to do, we need to, of course, measure distance A, not measure, why I'm talking about measurements, sorry. And we need to calculate, of course, A and B. So how to calculate? So A is normally AC and B is BC length, right? Corresponding length. So as we noticed before, in order to find horizontal or vertical distance between 2 points, we just simply need to have a difference of their respective coordinates. For example, if we talking about BC segments, they have horizontal coordinates y, that's the same both for C and B. Okay, for example, let's set up point A, maybe it's 1 and 3, 1 for x means here, and 3 for y. And here we need to have coordinates for B. So let's say this level for y it's 1 and 4 units here, all right, for x. So that's why this level becomes level 1, okay? That's why it tells you. So that's why in order to find BC distance, we just need to subtract from 4, 1. Okay? Basically, it's change in x coordinates. So it's 4 minus 1. So in order to calculate A, we need to do the same but for y coordinates. From 3, we need to subtract 1. And that basically change in y. Okay, so put red here, and I will say that this is change in x, and this change in y. So I use delta symbols, and each delta means difference. Okay. So AC, it's basically change in y, and in numbers it's 3 minus 1. That's how we can find corresponding segments. Now we know legs. 3 minus 1 is 2, and for B we'll have 3. In order to calculate, we just need to square up our numbers, our sides, and plug into Pythagoras theorem. Alright, height will be equal to 2 squared plus 3 squared. That will give you, so 4 and 9, 13. Okay, so in this case, height becomes a third, because you can evaluate square root of certain, but it's going to be third over a rational number. Okay, that's third. So leave answer as it is. So that's how we can find the distance between 2 points. So to recap one more time, in order to find the distance, I'll do it just one new example. So yx. So let's say we have a segment, we have AB coordinates, AB points with the corresponding coordinates, and now in order to find AB as the distance, you simply need to find change in x coordinates between A and B, square it up, and add change in y coordinates, square it up. Okay? So I can mark here on this figure that this is delta x, this lines, and this lines, delta y. Okay? Now you just apply Pythagoras, so it's about Pythagoras. Okay, don't worry if you have delta x, delta y negative values. You square it up, they becomes positive, so don't care about signs. Because it might be the case when you take difference in coordinates, they might be negative. Okay, so I think that we've got this idea how to find the distance between 2 points, so we just can apply that. So midpoints, I'll do quick. So midpoint is the point that is in the center of the segment. So let's say this is segment, so we need to find m coordinates as the midpoint. So this is the midpoint of the segment. Let's say AB, segment AB. Then in this case, if we just simply have those points so that they have the same level for y, actually m coordinates will be some x unknown, and y should have the same coordinates as for B and A. Okay, so that's why we just need to figure out x coordinates. So in order to figure out x, let's say this is xa and this is xb, what we need to do, we just simply need to have, so x and midpoint, this one, x midpoint is just simply arithmetic mean. So xa and xb, you need to add them up and divide by 2. That's basically arithmetic mean, right? Okay, but what if you have segment that's probably inclined, so it has some angle to y and x-axis. Okay, let's say A has coordinates xa and ya, and for B you have corresponding coordinates xb and yb. In order to calculate a midpoint, so it's not midpoint, actually, to be precise, it should be somewhere here. In order to calculate midpoint coordinates, you simply need to do the following. You need to x midpoint, y midpoint. So you simply need to say the following. For x m, it will be arithmetic mean for x and coordinates for a and b. And for y of the midpoint, it's going to be an average arithmetic mean for ya and yb over 2. Okay, so you see the strategy is pretty the same, but you apply separately for y and x coordinates, and that's how you can figure out midpoints. Okay, if you wanted to have a proof, if for some people who wants to know why is that, just simply have a look here. If you just again put 2 lines, so you build up to triangle again, so you understand that this midpoint and this horizontal line will intersect segment AC and the midpoint, right, of the segment AC, so it's here. And the same you can say about BC segment. So X midpoints and Y and midpoints. So in this case, you can say that this becomes a midpoint for segment AC, and this becomes X midpoint for BC, all right? And you just apply the previous concept for a straight line segment that's horizontal, for example, or vertical, no matter. And you do the same, okay? So I hope you understand how it works and just be able to calculate, just applying this set of formula. And we move next. So we got midpoint. Now, a few words about the gradient. So actually in the topic of straight lines, I've already shown that how we can calculate the gradient. So, but anyway, let's clarify this concept here. So how to find the gradient of the segment O line containing this segment. For example, we have the following. Let's say this again, y-x, Cartesian plane, and we have, say, line. This is a straight line. So we have 2 points on this line, let's say A and B, and we want to calculate the gradient. So what we need to do, in order to calculate the gradient, and what gradient is just by definition, gradient is the same as the slope of the line. It shows on the line or a segment. In this case, line or segment doesn't matter. So what does it mean? The gradient is the slope. It shows you just how steep your line. Okay, it shows you a degree of how like your line steep. Okay, it might be really steep like that, it might be less steep. And for this to measure, you just need to have, you know, some measure to identify a steepness of the line. Okay, So how to figure out the gradient? In order to define the gradient of the line or a segment, obviously you need to have coordinates. Let's say this xa, this ya. And for b, you'll have the same x, xb, and yb. Alright, so in order to calculate the gradient, you just need to, again, use the same approach as we did. So we did many times, right? We inscribed right angle triangle. For which reason? Because we want to identify how much change in x coordinates you have, and using this change in x, how y coordinates are changing. So in order to clarify what it means that if for, let's say, 1 unit for change in x, your line or your segment has a change in y for 2 units, so you're saying that your gradient is 2 in response to 1 unit change in x. So that's why we can define the gradient in the following manner. We need to take the ratio of how much you have change in y for unit change in x. Okay, that's gradient by definition. And indeed, for example, let's say we have this for, like, let's say 1 segment, and let's compare it with another segment that's less steep. And for example, we again use unit change in x equals 1, but in this case we'll have change in y. This was change in y 1. This is for another segment, change in y 2, and let's say it's 1. So gradient for the second line versus the first, this is, let's say, L1 and this is L2. So we'll have different changes in y. So here, change in y represent 2 units for unit step for x, and for line 2 we have just only 1 change in y. Okay, so that means this line is steeper than line 2, and using the formula we can calculate corresponding gradients. So gradient for L1 is simply 2 over 1, so which is 2, and gradient for line 2 is 1 over 1, or just 1. So the less the value, the less the degree of steepness. Okay, line 1 is more steep. Of course, we might have probably negative gradients, right? For example, let's have a look at this example. So we have yx, and let's say this is negative gradient, obviously. And let's see, for example, we have 2 points, A, with coordinates, let's say 2, 0, 0, of course, 2, yes. And let's say we have B coordinates, let's take it's 4 for x and 0 for y. So it means that that's 4 and that's 2 for y. Okay, how to calculate the gradient one more time? So the gradient of segment AB is simply change in y over change in x. Okay, so simply we can say that change in y is here and change in x is here. And let's say we start from point A, and just we moving down along segment AB. So we start from point A and we finalize at the point B. So how to calculate change in y? Change in y negative if you start subtracting from coordinates B, coordinates A. So let's calculate. So for y, we have 0 minus 2, okay? So 0 minus 2, it's negative. And you see that if you move down from A to B, you first like moving down by y, along y-axis, and then you move along x-axis. So for x, change in x is going to be positive. It's from 4, you need to subtract 0, right? So you'll have 4. So gradient AB becomes negative 2 over 4, or negative 1 over 2 if you cancel. So that's gradient, which is negative. So one more time, in order to define gradients of segment or line, you need to have 2 points. Or at least you need to be able to define coordinates of the points that lay on the line. In this case, you will calculate the gradient as just change in y, that's the top, and you divide by the change in x, that's the bottom part of your fraction. Or you can, like for simplicity, you can define gradient as vertical step over horizontal step. Okay, that's the same. So in terms of step, I use what we started in order to define points, right? We moving from point A to point B. Okay, first vertically and then horizontally. That's how it works. Okay, so that's actually what is called the gradient formula, or just the gradient. So maybe let's try to define gradients for specific lines. Let's say we have y-axis coordinates and we have, say, first horizontal segment. Let's say it's at the level of 4, and this 1, and this, let's say, 5. Okay, so we have 2 points A and B. How we define the gradient? So gradient by definition again is change in y over change in x, and we can say that is basically 4 for A minus 4 for B. Okay, so what we have nothing changing in along y-axis. So indeed, so those points are at the same level. And change in x, we have, if we start from A, normally move here, so it's 5 minus 1, right? It's 4. So actually it's 0 over 4. The gradient is 0. So the steepness of the line is 0, and indeed, so the gradient for this line it's 0. This line is not steep at all. In contrast, let's compare it with another line segment. Let's say CD. Now it's fixed at the level of, let's say, 2 for x. And you have 1 for C, that's y coordinate. So C has 2, 1. And D, let's say, has 7 for y. So 2 for x and 7 for y. So in this case, it's absolute vertical segment. Let's calculate the gradient. That was gradient for AB. And now let's calculate the gradient for CD. Okay, so gradient for CD. All right, let's see. It's equal to change in y over change in x. So start from, let's say, D. Now we're just moving down. You see that step 7 to 1. Okay, might be negative, but we can move the way back. So in order to, in order to have more proper values for changing y, so we starting from C and we moving up to D. All right, so changing y becomes 7 minus 1. Okay, it's better. And changing x to minus 2. All right, so what do we have here? We have 6 over 0. Okay, you know that you cannot divide number by 0. This sort of uncertainty, and it will give you an error. So the calculator machine will drop an error. So it's sort of error, but what it means in terms of gradients, it just means it's not available. It's not defined, okay? So the gradient for a vertical line is not defined. For those who understand that if you divide by a very, very small number, that's very, very small number, I mean very close to 0, you might consider it as like a number with multiple of 0, we say millions of zeros, and somewhere in the end is 1. That's actually the number that's almost 0. And if you do this operation in calculator, you'll get a very big number. Very, very big number. Okay? So scientists used to say that you'll have infinity. Okay? So the gradient just simply becomes infinity. It means that for very, very small step for x, your function change considerably. Okay, now in our case, the step is infinite small, but you have not like finite change in y value, as that is 6. And in this case, you'll have very, very big number that tends to be infinity. But anyway, infinity is sort of like abstract term, and that's why you're just saying that gradient for vertical line is not defined. Okay. So yeah, I think that we discuss the idea of the gradient. So we can say we mark it as we're done. So final topic is about parallel and perpendicular lines. Okay, I'll just show you very quick and we finalize. So we have the following: y, x, and we have, say, 2 lines that are parallel. For example, this is the first line, the red, this is the second line. So what does it mean parallel? It means that in terms of distance, whenever you take the point on line 1 and put perpendicular, so you'll have the same distance here as anywhere whenever you take in the point. So all those distances will be the same. So distance means like right angle to both lines, the shortest distance, right? But okay, let's say we have 2 parallel lines and we want to identify what's happening in terms of gradients. So what can we say about their gradients? So for this reason, let's say we have 2 points here and 2 points here, so that A, B, and say C, D lay on lines, and for example A and B have the same coordinates for y. This is, let's say, 3, different coordinates for x, and we have C and D exactly on the same level, but let's say difference, that would be 6. Okay, so in both cases we have rise here and here by 3 units up. Okay, so that's change in y. in order to define gradients, we just simply need to again apply this formula. And if we want to calculate the gradient 1, it will be 3 as change for y. So for gradient 2, we have the top identical, so 3. Now let's see what about change in axis. So let's say this is 1 and let's say this is 2, and for C and D we'll have 1.5 and 2.5. Okay, if we take change for between A and C, we'll have 0.5 change for x, right? And correspondingly here 0.5. So it looks like the gradient the same, okay? And it should be the case, okay? So two parallel lines should have equal gradients, so their gradients equal to the same amount or to the same values. 3 over 0.5 becomes 6 and 6, all right? So it means that if you have two parallel lines, their gradients should be the same. In terms of the equation of straight line, so for those who are not confident about equation, just try to watch my straight line topics, straight line 1 and 2. I was explaining the gradients concept and apply it to equations of the line. So here or there you can find equation of the line. So but typically it looks like mx plus c. So m stays for the gradient. So if we consider two equations for two lines, let's say L1 and L2, in terms of gradients, they should have the same m coefficients, but probably different c, okay? So the gradients are identical. Okay, what about perpendicular lines? So what if lines are perpendicular to each other, or segments? So for example, we have one line, L1, and another line, L2. What can you say about the gradients for each line, how they are interrelated? So we want to connect the gradient 1 and gradient 2 as gradients of corresponding lines. Okay, so what we can say about them? So typically they have a right angle, so they are perpendicular. You can mark L1 is perpendicular to L2. That symbol means perpendicular for lines or segments. Okay, so what we can say about their gradients? So actually they connected as gradient of the line 1 should be reciprocal to the gradient of the line 2 with negative sign. Okay? How to prove that? So I'll just show you on numbers. Let's say we have one step here and let's say 2 steps here. Okay? So the gradient of the line 1 should be 2 to 1, okay, which is 2. So this is for L1, so gradient 1. Okay, in order to define gradient for line 2, actually it will be great if we have like the grid lines, but trust me, if you have 1 step here and 2 steps here, so for the line 2 it will be reciprocal, so you'll have 2 steps here and just 1 step down. Okay, and in terms of, because it's down, so I mark as negative, and in order to calculate gradient 2 we just need to divide -1 over 2. And as you can see, they are in reciprocal ratio. So that's the standard formula that connects gradients of perpendicular lines. Okay, So that how it works, okay, in general. So lines perpendicular should for two lines that are perpendicular, you need to have this to be fair. Okay, so we briefly finalized the concept of coordinate geometry, and now we can apply it to straight lines, to some geometrical problems, probably to triangles where you need to combine geometry and coordinates geometry, right? Or probably topics from straight lines. Okay, just feel free and always use this coordinate geometry as the reference in your first studying and in your and now the different problems. Okay, so thank you guys, see you soon.